Hey everybody, and welcome back to another video. In this video I'll be going over the definition of the derivative using the limit to solve it. Now I'm doing this because it's a very common exam question that you will encounter in Calc 1, 100%, and I just want to show a conceptual and visual way to look at this rather than just mechanically doing it by the steps that you're supposed to do. And it'll hopefully give you some inspiration for other concepts in calculus which are very interesting. We're going to work with a simple function, x squared. So it's going to be called f of x. F of x is just a function of x. So imagine a machine, right? Two holes, one in, one out. You put in an x, you get a y. Or an f of x, okay? Function of x. In this case, we're going to be working on the xy plane. So our f of x is essentially y. Okay? Now, we're going to use x squared. It's going to look like that. Now, differentiation, so the derivative. At a point on a curve, we want to find out the slope of the curve, right? So let's say let's just zoom in only on the positive side here. Let's say we want to know, let's say we want to know the slope at this point, so this line. How do we find that out? Well, two smart guys, Isaac Newton and Leibniz, I think his name is. They I don't know which one of them did, but they thought, well, if we want to know the slope at this point, how about we draw a point here, aka this point, and then we just draw another one, draw the slope between them, which is not going to be accurate to this at all at this point. And what if we slowly bring this point closer and closer to this point, right? So basically this is going to go this way, this will move this way, until it reaches that point, which is infinitesimally close to that point, which could serve as a pretty darn accurate representation of the slope that we were looking for in the first place, which is the whole concept behind differentiation in a nutshell, okay? So let's get right into it. At this point, we can say it's point x, okay? This is just an arbitrary point on the x-axis. X-axis, y-axis, okay? Now, let's say that this next point is an h distance away, which makes it x plus h, okay? Very simple. This is h because x plus h, aka this distance, minus x, just equals h, okay? Just to reiterate. Now, what do we know about slopes? From pre-cal, we know a slope is just rise over run. What is our rise here? Well, as you can see on an xy plane, you put in an x, you get a y on the y-axis. So this will translate to a point on the y-axis, which we can call f of x for the x value, and f of x plus h for the x plus h value. What is our rise here? This is our rise, right? So it's the difference between the larger number, f of x plus h, and the smaller number, f of x, which is f of x plus h minus f of x, okay? Now, for the bottom, we want to know the run. So basically, we want to know this. This is the rise, this is the run. Our run, we just said it's h. There you have it. Now, this slope is between the 2 points. We want to bring this point as close as we can to the other one. How do we do that? Well, lo and behold, here comes the limit as h approaches 0. There you go. This is, you derived now the definition as is going to be shown to you in class. And yeah, so now let's try to differentiate this function using the limit. Just a few key points and then we're good to go, I think. So again, here's one key point. We know that f of x is x squared. So this is fine. We can just substitute it here. F of x plus h, what does that mean? It does not mean x squared plus h. That does, no. I've made that mistake many times. It actually means x plus h all squared, okay? Because when you have a function, for example, x squared, it has an exponent of 2, which means that, so this exponent affects anything that could be that x. And if we want to make our x plus h, aka just our original x plus a little bit of h, so it'll just increase it by a certain amount, or depending on h, if it's positive or negative, it's going to alter in some way, but it needs to be accounted for under the exponent. That's why we go with x plus h. All over h, make sure you write your limit every single time. You will lose marks for it. I know personally that will happen. And it's pretty simple from now on. It's an easy limit. Open it up, x squared plus 2x h plus h squared minus x squared all over h. These two cancel. We can pull out an h here. Let's see. We don't need this one. Make sure you write your limit every time. As h approaches 0. Here we can pull out an h. I believe I said that. 2x plus h all over h. Another good indicator at this point, when you're doing the definition way, which you're going to have to, I'm going to keep emphasizing that, it's going to be a couple of these lines, right? It's going to be like, okay, limit this, we cancel that. Limit this, we open the brackets. Limit that. At some point, the h at the bottom will have to cancel, okay? Because as the limit of as h goes to 0, 0 can't be on the bottom, okay? So we're in good waters here. So we can have limit as h approaches 0, 2x plus h, because we canceled this other one. We know that if h goes to 0, and it's just a polynomial, it's not a fraction, boom, see you later. H, take that, huh? And we're left with 2x, which is the differentiation of x squared, okay? Now let's do it the easy way, or the easier way. Honestly, it's the easy way. Let's take a harder function this time. Let's do 3x squared minus 2x plus 1. The derivative of a constant, okay, the derivative of a hold on, how does it go? The derivative of a sum is the sum of derivatives, I believe. So you could just literally go d dx 3x squared minus d dx 2x plus d dx of just 1. Now, d dx of 1, the derivative of any constant is 0 because the slope is 0. It's not changing. Now, for these other ones, if they have an x, so any x that you have, essentially, even this one, here you have an x, except it's to the power of 0. Here it's to the power of 1. So the trick is behind doing it the easy way. You take the exponent on the x, you multiply it by the coefficient in front. In many cases, this is going to be 1, right? X squared has a coefficient of just 1. You multiply it, so let's see, what do we get? We get 6x, because we took the 2, we multiplied it by the 3. And then you take the 2, you subtract 1 from 2, and that becomes your new exponent, 1. But obviously 1 is just itself, so. Minus 2x. Remember, if you have a coefficient times an x, you differentiate it, you only get the coefficient. Because why? You have the coefficient, or the exponent, it's 1. 1 multiplied by 2 is 2. X to the power of 1 minus 1 of 0. Anything to the power of 0 is just 1, so you just get the coefficient. And then we concluded that this becomes 0. So this is the differentiation of this function, the easy way. You could do it the limit way for some practice. You should actually, after, you should just pause it. Well, at this point, I guess you watched it, but draw yourself a function, just random one. Use the limit and then use the easy way and then see if they match. If they do, you're cool. If not, just watch this video again and you'll get it. I hope you enjoyed the video. Hope you learned something new. If you have any questions or comments, please let me know. Other than that, I hope you enjoy your day and please subscribe and like the video and see you later. Bye-bye.